students, welcome back to the video tutorial classes run by Great FM and Great TV. My name is Madan Gopal Pantar. I am teacher in the school Deji School, Khairini Nagar Palika, Chitwan. Today our topic is force. So in the topic we are discussing about the types of force and importance of force. Firstly, we should understand force is a very inseparable matter from our childhood, isn't it? From during walking, we have been using force. Force are generally used in two traits, pull or push. So in this way, by the direction force, there are two types of force. Pulling force and pushing force. But force is also has the category on the basis of physical contact and non-physical contact. So in the same way, there are two types of force. One is physical contact force and the other is non-physical contact force. So I'll show you in the board by the category. So dear students, look in the board. Force is generally of two types when we talk by the use of direction. That is pulling force and pushing force. But in the same way, force can be categorized as two types on the basis of our physical contact. That is physical contact force and non-physical contact force. Pulling force भनेको चाहिँ when we push something, then we apply a force. That is called pulling force. In the same way, the force used while pushing the object is called pushing force. So when we push any object, rickshaw, when we push buses, then the force is called pushing force. And pulling force in the same way when we pull some object. Remember, we pulled many objects in our daily life. Now let's go back to the second category, physical contact force. For example, we have talked in our lower class about frictional force, about muscular force. Look, when we walk, we have produced frictional force. But we should remember there is the physical contact, our body, and there is ground. That is physical contact, frictional force, muscular force. They are the types of physical contact. Now, non-physical contact, the force which are produced without the non-physical contact of the body. For example, gravity. Remember, gravitational force. They are non-physical contact force. And today we are concerned here to talk about the gravity, the gravitation. Remember, so in the lower class also, we have discussed about gravity, isn't it? So if you remember in the class 8, class 9, there are some small introduction about gravity and gravitation. So same, today we are talking about gravity and gravitation. So look here, gravitation. Now, the history of force, gravitation, it is a way long back. यो धेरै समय अगाडिदेखिको यसको हिस्ट्री छ ग्रेभिटेसनको. So when we talk about gravitation, we should not forget the formation of our solar system. We have been taught, you all are taught that the formation of solar system is the basic of gravitation. यो solar system भन्दाखेरि चाहिँ ग्रेभिटेसनको एकदम मूल तत्त्व त्यहाँ रहेको हुन्छ भनेर हामीले बुझ्नुपर्छ. सूर्यले एउटा प्लानेटलाई, सनले एउटा अर्को प्लानेटले फेरि अरू प्लानेटलाई एक आपसमा ग्रेभिटेसनको फोर्सले तान्दाखेरि चाहिँ यो सोलर सिस्टमले नियमित रूपमा एकअर्कालाई घुम्छ भनेर हामीले बिर्सिनुहुन्न. त्यही अर्थमा चाहिँ सेकेन्ड सेन्चुरीमा एउटा थ्योरी बनेको थियो. त्यति बेलाका जान्ने सुन्ने फिलोसोफर भन्छौँ हामी, उनीहरूले एउटा थ्योरी बनाएका थिए. त्यसलाई हामीले हेलिसेन्ट्रिक थ्योरी भन्छौँ. हेलिसेन्ट्रिक थ्योरी अनि अर्को छ जियोसेन्ट्रिक थ्योरी. रिमेम्बर, त्यो जियोसेन्ट्रिक थ्योरीमा चाहिँ के छ भने जियो भनेको अर्थ, जियोले अर्थलाई डिनोट गर्छ जियो अर्थ यो जियोसेन्ट्रिक थ्योरी means the theory which says earth is in the center and other planets are revolving around the earth, that is called geocentric theory. यो चाहिँ 2nd सेन्चुरीमा त्यति बेलाको जान्ने सुन्ने फिलोसोफरले भनेको चीज जियोसेन्ट्रिक र अर्को छ र यो जियोसेन्ट्रिक थ्योरी धेरै समयसम्म बस्यो किन त्यति बेलामा मान्छेलाई त्यही सही लाग्थ्यो they believed the earth is at the center because they see daily the sun being moved, not earth. धेरै समयसम्म यो थ्योरीले काम गर्यो तर यसको 2nd सेन्चुरीबाट 17th सेन्चुरी यति लामो ड्युरेसन द लङ ड्युरेसन यही जियोसेन्ट्रिक थ्योरीले काम गर्यो त्यति बेला मान्छेहरूलाई थाहा थिएन दे डिडन्ट नो अबाउट द सन इज एट द सेन्टर 17th सेन्चुरीमा गएर बल्ल निकोलसले चाहिँ के कुरा भन्यो भने वाट डिड ही से रिमेम्बर by the use of his own made microscope he observed उसले आफैले हेर्यो वास्तवमा सूर्य हैन रहेछ सो वास्तवमा चाहिँ सूर्य हैन रहेछ घुम्ने त हाम्रो पृथ्वी रहेछ 17th सेन्चुरीमा त्यो चाहिँ 15 सेन्चुरी शताब्दीको ग्यापमा गएर अनि बल्ल एउटा थ्योरी आयो जसलाई हामीले हेलियोसेन्ट्रिक थ्योरी भन्छौं हेलियोसेन्ट्रिक थ्योरी theory अघि मैले भनेको थिए जियोसेन्ट्रिक व्हाट डिड आई टोल्ड जियोसेन्ट्रिक सो माय डियर स्टुडेन्ट्स फर द क्लास 10 स्टुडेन्ट्स रिमेम्बर दिस टु थ्योरी यो चाहिँ हामीले तल कक्षामा यसको बारेमा चर्चा गरेका हुँदैनौं यो नयाँ हो तपाईहरुलाई यो एकदम इम्पोर्टेन्ट पनि छ एक्जामको लागि सो द टु थ्योरीज आई टॉट जियोसेन्ट्रिक 2nd सेन्चुरीमा त्यसपछि आफ्टर 15th सेन्चुरी we have heliocentric theory. So geocentric theory means the theory in which the earth is believed to be at the center and other planets are revolving around it. This is geocentric theory. And the heliocentric means not earth, sun is at the center. Remember, sun is at the center and other planets, satellites, they are revolving around the sun. That is called heliocentric theory. त्यसपछि after that the rise of Newton took place. What we call Newton भन्नेबित्तिकै हामी चाहिँ great scientist को कुरा गर्छौं. The rise of Newton took place and Newton bring about the theory of gravitation जुन हामी कुरा गर्दै छौं. Gravitations. Newton has a various accident हामी कुरा पनि गरेका छौं. न्यूटन को सँग भएका घटनाहरू न्यूटन चाहिँ आफ्नो गाडीमा बस्दाखेरि त्यसपछि विभिन्न घटनाहरू स्याउ खसेका कुराहरू यो विभिन्न कहानीमा पढ्न पाइन्छ र न्यूटन्सलाई वास्तवमा असर पारेको पनि त्यही चीजले हो आफ्नो बगैँचामा बस्दाखेरि स्याउ खस्नु उनको लागि त्यो संयोग परेको उनले त्यो सोच्नु यहाँबाट विभिन्न धारणाहरू आयो र अनि त्यसपछि न्यूटनले ग्राभिटेसन भन्ने चीजहरु पत्ता लाग्यो र यो ग्राभिटेसन भनेको चाहिँ मास सँग रिलेटेड छ जहाँ मास छ त्यहाँ एट्र्याक्सन छ कुनै एउटा मासले अर्को मासलाई आफूतिर तान्ने द एट्र्याक्सन फोर्स अफ टु मासेस टुगेदर इज कॉल्ड ग्राभिटेसन यो ग्राभिटेशन्स हाम्रो युनिभर्समा जहाँ पनि पाइन्छ देयर इज ग्राभिटेशन्स एमंग टु ऑब्जेक्ट्स एनी टु ऑब्जेक्ट एकदमै सानो माइक्रो एकदमै ठुलो मैक्रो माइक्रो र मैक्रो जहाँ पनि यो एट्र्याक्सन चाहिँ देख्न पाइन्छ this is called gravitation but sometimes we feel is there really gravitations if there is gravitations then why I am not attracted remember dear students you should think over it यदि जहाँ पनि ग्राभिटेशन्स छ भने हामी चाहिँ एक आपसमा गएर किन टाँसिदैनौं त हामी त फ्री भएर हिँड्छौं ग्राभिटेशन्स न्यूटन्सबाट पढ्यौं भने फेरि संसारको जहाँ पनि छ भनेर भनिन्छ तर ग्राभिटेशन्स हामीमा चाहिँ किन फिल गर्दैनौं दुईवटा अग्ला अग्ला घरहरू टु भेरी टल बिल्डिङ भेरी नियर तिनीहरु टाँसेका छैनन् त मासको कुरा गर्ने हो भने त फेरि त्यो घरको मास त धेरै छ धेरै मासको धेरै ग्राभिटेसन हुन्छ भनिएको छ यो कुरामा कस्तो हुन्छ भने सो आई लाइक टु गिभ यु द एक्जाम्पल अफ म्याग्नेट्स रिमेम्बर विद्यार्थी भाइ बहिनीहरूलाई यसमा चाहिँ अलिक कन्फ्युजन छ भने यो सब चुम्बकको उदाहरण दिँदैछु मैले। एउटा ठुलो चुम्बकको माथि सानो सानो चुम्बक राख्यो भने त्यो सानो सानो चुम्बकहरू एक आपसमा टाँसिन्छ त? टाँसिँदैन, किनभने त्यो ठुलो चुम्बकले को आकर्षणले त्यो सानो सानो चुम्बकको आकर्षणलाई चाहिँ विलीन गरेको हुन्छ, नेग्लिजिबल गरेको हुन्छ भनेको हो मैले। त्यस्तै नै हो यो हाम्रो अर्थको मासको अगाडि यो बिल्डिङको मासको चाहिँ फेरि के भयो त? एट्र्याक्सन हरायो, नेग्लिजिबल भयो। त्यसले गर्दाखेरि ग्राभिटेसन्स हामीले अर्थमा फिल गर्दैनौँ र ग्राभिटेसन्सलाई हामीले विक फोर्स पनि भन्छौँ। रिमेम्बर, सो इफ इट वाज नट इन द अर्थ देन देयर वुड ह्याभ द building would be collapsed there. Remember, so this is what is about gravitations. Now I would like to go about the Newton's law in the gravitations, dear students. So what I told you, remember, I started from point wise. I am telling you again: geocentric theory, heliocentric theory. It is very important for you to remember. And then I talked about gravitations. Remember. So what is gravitations? The attraction force between any object at any place of universe is called gravitation. Newton is a person who established the gravitation. So we have a famous universal law of gravitation given by Sir Isaac Newton. So in this law, he has explained the property of force, which is as follows: the attraction force between two bodies is directly proportional to the product of masses and inversely proportional to the square of distance between them. This is called Newton's universal law of gravitation. So this is another part of this topic, that is Newton's universal law of gravitation. My dear students, so this is very important for you again. Newton's universal law of gravitation. So in this law, Newton has tried to explain the experience among two objects. So what he has explained is, in the first line, the gravitation of the two objects depends upon the mass m1 and m2. And again the second part is distance between their center, that is d. So the law goes like this: the Newton's universal law of gravitation states that it depends directly on the product of two masses and it depends inversely on the square of distance between their center. So this is very important thing for you to remember in this topic. So I am writing important here again. Mark it. Newton's universal law of gravitation. So I am going to write you this law for you because it's very important. Now everybody look my line. It states that the force of attraction is directly proportional to product of two masses and inversely proportional to square of distance between their center. So dear students, I would like you to give your attention in this law because from the exam point of view also it is very important. Newton's universal law of gravitation, and again we are using this law to prove a very important formula, that Newton's universal law of gravitation produces that is used in the various numerical solving. भनेको कुरा बुझ्नुभयो होला हामीले यो ललाई चाहिँ एकदम ध्यान दिएर पढौं र अब यसबाट हामीले एउटा इम्पोर्टेन्ट फर्मुलाहरु चाहिँ यहाँ बनाउँदै छौं जुन चाहिँ हामीले विभिन्न किसिमका गणितीय साइन्सको गणितीय समस्याहरु चाहिँ सल्भ गर्दा पनि काम लाग्ने भएको हुनाले अब हामी म तपाईलाई त्यतिखेर लाँदै छु न्यूटन्स युनिभर्सल ल अफ ग्रेभिटेसन हैज गिवन अ भेरी इम्पोर्टेन्ट फर्मुला यो लबाट एउटा इम्पोर्टेन्ट फर्मुला बन्दैछ रिमेम्बर सो हामी अब त्यो लाग्दै छौं सो प्लिज गिभ अ कन्सन्ट्रेसन हियर proof of G equals to F equals to G m1 m2 by d square ल यही नै हो हामीले प्रुफ गर्न लागेको फर्मुला दिस वान इज द भेरी इम्पोर्टेन्ट फर्मुला that is given by Newton's universal law of gravitation. So now dear students, if you give your attention very clearly, you will find the two sentences being attached here. For example, the force of attraction is directly proportional to the product of two masses, one sentence. And again, the force of attraction is inversely proportional to the square of distance between their center. There are two sentences given by Newton's universal law of gravitation. So now I'll take you to one by one. So the proof is given in this way. Look here. The first sentence, force E of attraction is directly proportional to the product of two masses. So I'm writing this symbolically from Newton's universal law of gravitation. Newton's universal law of gravitation बाट हामीले के प्राप्त गर्छौं भनेको हो यसमा पहिलो भागमा हामीले हेर्न सक्छौं the force of attraction is directly proportional to the product of two masses अर्थात force of attraction F directly proportional product of two masses m1 m2 and again if you look back to the second sentence the same force of attraction is inversely proportional to the square of distance between your center. So I am writing the second sentence again. The same force is inversely means 1 by indirect भनेको 1 by square of distance d square. So the both quantity being related to force, now we are combining. यो दुवै क्वान्टिटीहरु फोर्स सँग रिलेट भएको हुनाले डिपेन्ड भएको हुनाले now we are combining. हामीले अब यसलाई कम्बाइन गर्दै छौं है. So combining both. अब के हुन्छ? What do we get? Can you please tell what do we get? So we get force proportional m1 dot m2 by d square. So we get this. Now, so there is proportional. Remember, proportional means it depends. It is not exactly the equal. Remember, it depends. Proportional means. So whenever we are making the equal sign, we have to add a constant here. यदि कोही नेपाली माध्यममा पढ्ने भाइ बहिनी छन् भने यहाँ राम्रोसँग ध्यान दिने. यो कम्बाइनिङ गरेपछि जुन हामीले यहाँ प्राप्त गर्यौं यो चाहिँ फोर्स डिपेन्ड्स अपन m1 m2 by d square भनेको हो. यो डिपेन्ड्स भनेको चाहिँ बराबर भनेको होइन. बराबर भनेको यसलाई बराबर गर्नको लागि हामीले कन्स्ट्यान्ट चीज राख्नु पर्छ जसको भ्यालु सधैं एउटै हुन्छ. र यसलाई मैले अहिले f equals to g m1 m2 by d square where g is proportionality constant called gravitational constant. So my dear students, So I'd like again you to revise it, because this one is an important portion that we are discussing today. First, I told you about the Newton, his famous law. It is also called universal law. Don't forget the word here, universal. Universal, विश्वव्यापी. जहाँ पनि universal law. It is applied over any part of the world. Universe. So it is called universal. Law of gravitation. This law is very famous because from this law we can formulate a very important formula from which we can calculate the gravitational force between two objects. So, dear students, I hope you understood the Newton's universal law of gravitation and the formula related to Newton's universal law of gravitation. On my next class, I will show you the numerical solving by using the same formula, F equals to G m1 m2 by d square. Keep tuning this channel and wait for my next video. Thank you.